Hello. So if we're looking, remember to perfect squares, if when we were foiling, we remember that if we have the group a plus b squared, remember, like saying a plus b times a plus b, and that's like then that means it's a squared plus 2ab plus b squared, one of those shortcuts. And if we had a minus b squared, a minus b times a minus b, that being a squared minus 2ab plus b squared. These shortcuts we're now going to kind of look at going backwards. Now, the thing with taking these backwards, if you don't remember the shortcut or don't notice the shortcut, that's perfectly fine. You can just go the normal way and you'll see us at the end and it'll be the same answer. So, if we're going to determine if there's a perfect square, we need to see if the first term is a square, meaning it's a perfect square. The second, we need to realize if the last term is perfect square, And we then need to see if the middle term is twice the product. Or if we have 2ab in the middle. So that's going to be our criteria for determining a perfect square. Again, if you want to use this chicken technique going forward, great. If not, don't really worry about it. So if we look at 25 x squared minus 30x plus 9, we look, is the first term a perfect square? Yeah, we can say that it's 5x squared, and that makes 25x squared. Is the last term a perfect square? Yeah, we can have plus 3 squared. Now, is the inside twice the product? So do we have minus 2 times 5x times 3? That's minus 30x, so yes it is. And since we have minus here, we have that this is the group 5x minus 3 squared. Or we could say 5x minus 3 times 5x minus 3. That's a shortcut. If you don't recognize this, that's fine. See if there's a common factor. If not, multiply a times c and go from there. Now, looking at 49y squared plus 42y plus 36. Is the first term a perfect square? Yeah, we have 7y squared. Is the last a perfect square? 6 squared, yeah. Now, is 42 2 times 7y times 6? No, that's not. That is not. So this is not a perfect square. And in fact, this doesn't even work out, and this is prime. All right, so again, some of these perfect squares, if you can catch it, great. If not, awesome. Use your other techniques. That's perfectly fine. Now, when it comes to factoring in the general sense, we're talking about factoring. Like if it just said factor each completely, what do we do? This is really important that we understand this process. We need to remember that first and foremost, we always look for a GCF. Always, always, always do we look for a GCF. All right? So we're always going to look for a GCF. Next, if we don't have a GCF, we're going to check if we have two terms, do we have a difference of squares? Do we have a difference of squares? Like when we had a squared minus b squared or whatnot. Now remember, there is no such thing as a sum of squares. There is no such thing as a sum of squares. Now, after we check if it's a difference of squares, that has two terms. We could check if there are three terms. Is the coefficient greater than 1? Like, do we have x squared plus bx plus c, where we say like what multiplies to c and what adds to b, like say like m times p adds to, or is c, and m plus b is or m plus p is b, something like that. Or do we have ax squared plus bx plus c, where we have to then say ax squared plus gx plus hx plus c, where we do all of that and then we do our grouping. Do we have to check that? And then fourth and finally, we should check if we can use factoring by grouping. And then we might have to jump around. After we group, we might have to do a difference of squares, and that's okay. In our grouping, we're going to be looking for GCFs, but here's our 4 main things. First, we always need to check for a greatest common factor, and then we go from there. So if we look, and we have 2a squared b squared minus 2a squared minus 2ab cubed plus 2ab, and we're going to go and we're going to see, what is our common factor? Do we have one? It looks like we have a 2a in common, just singular 2a in common with all of these. So I'm going to have 2a, and let's see what's left. We have ab squared minus a minus, looks like b cubed plus b, looks like. So now I have 4 terms. Do I have a difference of squares? No, doesn't look like it. Do I have a trinomial? No. So I'm going to use grouping. So in this first group, ab squared minus a, what's my greatest common factor? I have a that I can pull out, and I'm left with b squared minus 1. Now, I want to be left with b squared minus 1, and I have negative b cubed plus b. I'm going to pull out negative b, so I'm left with b squared minus 1. Now, when I do the grouping and I pull those groups forward, I have 2a times the group a minus b times b squared minus 1. Now, just because I did that grouping, I can't guarantee that I'm done yet. I have to go back and check. 2a, that's fine. A minus b, that's fine. B squared minus 1. Oh, that's a difference of squares. We have b squared and 1's a squared. So I'm going to then have to say 2a times the group a minus b times b minus 1 times b plus 1. Now at this point, everything is broken down and I've completely factored it. But if you notice, I had to use a GCF and then grouping and then a difference of squares. And that's okay. Things might have to be factored more than one time. On our practice, we're on page 1231, 16 through 32 even. Number 62 says 24d squared plus 39d minus 18. If we look first, is there a greatest common factor? The people should all say yes. We can pull out a 3. So when we pull out a 3, we're left with 8d squared plus 13d minus 6. Now, since we have a trinomial with the coefficient in front that's greater than 1, we're going to multiply the first and last terms and see that we need what multiplies to negative 48 that adds to 13. So what multiplies to negative 48 that adds to 13? Well, let's see. We can have negative 12 times 4, but that adds to negative 8. Let's see, if we do 48 divided by 8, that's 6. That's not going to work. 48 divided by, let's see, 48 divided by 16 gives us 3. So if we have 16 times negative 3, that gives us our 13. So we can say 3 times 8d squared. Let's say, I'm going to say, oh, why don't we go with minus 3d plus 16d minus 6. Then when I apply my groups and I look 8d squared minus 3d, I can pull out a d and have 8d minus 3. And then over here, if I pull out a 2 plus 2, I'm left with 8d minus 3. So then I have 3 times the group d plus 2 times 8d minus 3. And I've fully factored 16. And if you have patience and you remember those 4 steps from the notes, you will be able to factor it all. Have fun!